In this lecture, we will continue our discussion of if statements. There are some cases where we can have a set of if statements and we really don't need to include the else, where we can just simply omit it and it does the exact same thing as if we had the else in there. So here is an example where we have some variable called day, and depending on the value, we print out a day of the week. So here, if day is 1, we print out Sunday. If that's not true, then we check if day equals 2. Then if that's true, then we'll print out Monday. And if that's not true, then we'll check to see if day equals 3. And if that's true, then we print out Tuesday. Now here is the exact same code, except I just took out the else parts. And this will pretty much work the exact same way, because what if day is 1? If it's true, we do print out Sunday, and I don't have to worry about any of the other parts. I will still execute the if statements here and here, but they're both going to evaluate to false. So we're going to skip the lines that say print Monday or print Tuesday. So this is just to show that the if-else statement is very useful. The else helps us making sure that we execute certain statements when it's false, but there are some circumstances where we don't necessarily need it. Another interesting feature about dealing with these logical expressions is that Java does it in quite an efficient manner. So let's give you an example. Let's say I check to see if x is greater than y or x is equal to 5. Well, what if the first part is true? What if x is greater than y? Then that means right there we already know that the entire expression must be true, because since this part right here is true, doesn't matter what the second part is. Whether it's true or false, the whole thing is true, which means we don't need to check if x is equal to 5. So what Java does is it'll evaluate that first part, and if it's true, then it doesn't need to do the x equals 5 because it just immediately returns that it's true. This is what we call short circuit evaluation, which just means that we evaluate our expression from left to right, and as soon as we know the value of the whole expression, we just stop evaluating. If there is no need to check different parts of our expression, then we just skip it and just return the final result. We're now going to address an issue when comparing doubles for equality. This is not an issue for integers, but for doubles we have to be very careful. So let's use an example. Let's say I have a variable y that's a double, and we initialize it to 3.0 divided by 7.0, plus 2.0 divided by 7.0, and then plus 2.0 divided by 7.0. This should evaluate to 1.0, because 3 sevenths plus 2 sevenths plus 2 sevenths is 7 over 7, which is 1. But because of decimal rounding, this actually turns into 0.99999999999, which means if I try to compare this to see if x is 1.0 and try to see if x equals y, this is going to become false. Now, mathematicians may argue about whether 0.9 repeating is equal to 1. We're not going to get into that right now. So how do we address this in our programs? Because y should be 1, but we're not getting 1. What we can do is check if the absolute value of the difference is within some threshold. So let me show you an example how we do that. So we're going to use the math.abs method, which does the absolute value. So we can just simply check if the absolute value of the difference between x and y is less than some threshold. So like 0.000001 or even 0.0001 or however many zeros. You can specify some very, very small number. And if the absolute value of the difference between the two numbers is small enough, then we say that's close enough, that should be equal. We'll now discuss a new operator that's used for comparisons, which is called the conditional operator. For any type of comparison, we can use a traditional if-else statement however we want. But in some circumstances, we can actually write our if-else statement more compactly or more concisely by using what's called the conditional operator. And this takes 2 operators and 3 operands, which is very different from any other operator you've seen so far. So far, we've mostly had 1 operator and 2 operands. So let's take a look at the syntax for it. So we have our condition, and then a question mark. And then we put in our true expression, and then a colon, and then a false expression, and then we end that with a semicolon. This line of code is the exact same thing as our traditional if-else statement. So if some condition, we do some true expression, and if it's not true, then we have our false expression. So the idea is we do our condition first, we put a question mark, and then we put in the statements that's going to be our true part. Then our colon represents the else part. So anything that comes after the colon means that we're dealing with the false portion of our statement. So let's take a look at a very simple example. This is actually a very common example that's used for implementing the conditional operator. So let's say I want to find the max of two different values. So how do we do that? Well, we'll see if A is greater than or equal to B, then the maximum is going to be A. And if A is not greater than or equal to B, then that means A must be less than B, so the max is going to be B. So we can rewrite this using a conditional operator. So we can set max to be equal to our condition right here is A greater than or equal to B. Then we have a question mark. So if it's true, then we're going to handle the true portion, which is to say A. So we're going to assign A to max. And if it's not true, then we handle the false portion, which means we're going to assign B to max. So notice that since this is an operator, it is going to evaluate to some value. So we can take our conditional operator and assign the result of it to some variable, which is what we're doing over here.